Let's look at the Unit 6, Lesson 8 practice problems. So number 1 asks us to classify the graph of this equation. So we want to take a look at it and see if we can recognize any features that would help us distinguish between these. So one thing that hopefully pops out immediately is that you have an x squared term and you have a y squared term. So for a parabola, you would only have an x squared term. For a line, you wouldn't have any squared terms. You would just have like y equals mx plus b or something like that. But your variable, your x and your y, would not be squared. Exponential, your variable would be in the exponent. So you would have something like this, e to the x or 2 to the x. But your x would be up in the exponent. A circle is the one that we've talked about that has both the x and the y variable being squared. For number 2, it says write an equation that states that the point xy is the same distance from the point 4, 1 as it is from the x-axis. So this is going to be writing a parabola. Since a parabola is the set of all points equidistant from a point called the focus, and then from the line, the directrix. So here's your focus, and here's your line, the directrix. So this one I like to write as a y equals line. So the x-axis is the line y equals 0. So if we remember when we're writing equations of parabolas, the distance to the y-axis is the same as to the point. So that will be on this side of the equation, we'll do y minus the y coordinate of your directrix. I'm just going to put y sub d, d meaning directrix. So that'll be our distance to our directrix. And then we will do the Pythagorean theorem to figure out how far the point is from the focus. And so this will be x minus the x coordinate of your focus. And then the y coordinate minus the y coordinate of your focus. And that's going to represent the horizontal and the vertical distance between the 2 points. So here would be your point xy. And here would be your point, the focus. Okay, so this would be your x of your focus and your y of your focus. And then the distance here, okay, is from the point to that directrix line. So y minus the directrix y coordinate. So in this case, we have y minus 0, since the directrix is 0, equals x minus the x coordinate of the focus. So the x coordinate of the focus is 4, plus y minus the y coordinate of the focus. And the y coordinate of the focus is 1. So that would be our parabola. Oops, I forgot. This should be squared. So then you could clean it up just by saying that this is just going to be y squared. And then this will just stay x minus 4 squared and y minus 1 squared. Number 3, select all equations that describe a parabola with a focus of -1, 7 and a directrix of y equals 3. So first off, let's just look at writing the equation of the parabola. So the distance to the directrix will equal the distance between the points from the point to the focus. So the distance to the directrix is y minus the y coordinate of the directrix. Then the distance between the points will be the subtraction of the x's. So we'll do x minus the x coordinate of our focus. So y minus -1, we'll turn that to +1 squared. And then y minus the y coordinate of the focus. So y minus -7, we'll turn that to +7. So that's our parabola formula that we've kind of been looking at. So now we can look at these first two that are written in that form. And we see that this one has x minus 1 instead of x plus 1. So that is not correct. This one has the x plus 1 squared, the y plus 7 squared, and it's equal to y minus 3 squared. So this is good. Then what they've done is taken this kind of directrix form here, and they've written it in vertex form. So they've multiplied out this y minus 3 squared. Okay, so a binomial squared, we know that's going to be y squared minus 6y plus 9. Now, all of these still have the x plus 1 squared, so we're going to leave that. We're not going to touch that, so we're just going to leave it as x plus 1 squared. And then we'll multiply out this y plus 7 squared. So that'll be y squared plus 14y. Now let me move this over a little bit here. Whoops. I don't know if it's going to let me. Let's see. Okay, let me move this over just a little bit so we have some more room. So that's going to be y squared plus 14y plus 49. So now they're going to bring all of the y terms to the left-hand side. So let's subtract this y squared from both sides. We're also going to subtract this 14y from both sides. And I just lined it up under its like terms. So y squared minus y squared is 0. 6y minus 14y is negative 20y. And we have that plus 9. And then equals x plus 1 squared. Y squared minus y squared is 0. 14y minus 14y is 0. And we have that plus 49. So then we'll subtract 9 from both sides. So we can get those constant numbers together. So then we end up with negative 20y. 9 minus 9 is 0. X plus 1 squared. 49 minus 9 is 40. So then we'll divide by negative 20 to get the y by itself. And you'll do that to each term on the right-hand side. So negative 20y divided by negative 20 is just 1y. And then for this one, x plus 1 squared divided by negative 20, I'm going to think of this as having a 1 up top. So 1 divided by negative 20 is negative 1/20. And then x plus 1 squared, 40 divided by negative 20 is negative 2. And then we can kind of match these up. So we see that it has a negative 2, so it can't be these ones with the plus 2s. This one has negative 20, okay, which is not what we want. We had negative 1/20. Okay, number 4 says parabola A and parabola B both have the x-axis as a directrix. Parabola A has its focus at 3,2. Parabola B has its focus at 5,4. Select all true statements. So I like to draw pictures of these to help. So we'll draw parabola A here. Whoops. So I'm just going to draw the XY axis here. And this one says that parabola A has a focus of 3,2. Okay, so it has a focus of 3,2. So we'll just put a point here. So here's our focus. And then it has a directrix of the x-axis. And so that's this line right here. And I also like to write this as the y line that it is. So this is y equals 0. Then, and that's parabola A. Then parabola B has a focus of 5, 4. Okay, so 5, 4. And then a directrix of the x-axis again, which again is the line y equals 0. So let's see if we can come up with which statements are true here. So parabola A is wider than B, or B is wider than A. So remember, the further the focus is from the directrix, the wider the equation is, or the wider the parabola is. So this parabola here is going to be narrower than this one, since the distance, since the distance here, okay, the distance from this focus to the directrix is 4 units, and this one is 2. So B's parabola will be wider. So B is wider than A. The parabolas have the same line of symmetry. So this is asking basically if they are at the same x coordinate, because the line of symmetry is going to cut right through the focus. So this one has a line of symmetry of x equals 3. This one's line of symmetry is x equals 5. So they do not have the same line of symmetry. The line of symmetry for parabola A is to the right of B, or B is to the right of A. So the line of symmetry, so let me just draw it over here again. So the line of symmetry for A is at x equals 3, right? So this is A's line of symmetry, and B's line of symmetry is at x equals 5. So which one is to the right? So B is to the right of A. Number 5, parabola A has a focus of 5, 1, and a directrix of y equals -3. What's the vertex? So remember, the vertex is directly between the focus and the directrix. So let's just draw a quick sketch here. So the directrix is down at y equals -3. And the focus is at 5, 1. So the vertex is going to be directly between these. It's also going to be on the same x line. So it's going to be on this same vertical line here, which we know, so we know the x coordinate will be the same. So the x coordinate here is 5. So we want to figure out the y coordinate that's in the middle here. Okay, so this one's at 1 and this one's at -3. So we could kind of draw these on here. So that's 1, -1, -2, -3. And you could find the middle that way. So then the direct middle between these would be at -1. So you could do it that way, and that would give you the vertex. So this is y equals -1. This would give you the vertex of 5, -1. Okay, you can also, so remember, we know that the x coordinate is the same as the focus. Okay, so we knew this was going to be 5. So again, we're looking for this y value here. and we want it to be in the middle of 1 and -3. So middle is just average, so you can take and add 1 and -3 and divide by 2. So 1 plus -3 is -2, divided by -2 is -1. That's another way you could get it. Okay, number 6. So select the value needed in the box in order for the expression to be a perfect square trinomial. So remember, this is where we take the middle term and we divide it by 2. So in this case, we'll get 3.5. And then we square this. And 3.5 squared is 12.25. Number 7, rewrite the expression as the product of two factors. So in this first one, we just have a common factor of x that we can take out. So we'll factor that out. So after taking the x out, so x squared divided by x, we're left with x. 3x divided by x, we're left with 3. Remember, you can look at this and make sure that when you distribute the x, that it equals back to this. So x times x is x squared, x times 3 is 3x. Factoring a trinomial. Now, this is not a binomial squared. We can tell because -6 divided by 2 is -3. And -3 squared is 9. So this is not like one of the patterns that we've been using. So we want to look for the numbers that will multiply to -7. Those will go in here, and they have to add to -6. Okay, so what numbers, and 7 is prime, so it's got to be 7 and 1. So what multiplies to -7? So either 7 times -1 or -7 times +1. And then we want to find the ones that add to -6. So 7 and -1 adds to +6, -7 and -1 adds to -6. So we want this to be -7 and +1. This next one, 4 divided by 2 is 2. And 2 squared is 4. So we know this is one of our perfect square trinomials. So this is x plus 2 squared. And then number 8, so suppose this two-dimensional figure is rotated around the vertical axis. Each small square grid represents 1 square inch. What's the volume of the solid that's created? So if we spin this around, okay, so if we spin this around, okay, this is going to create a circular motion here, right? And we've got this circular motion here, okay, connected. And then this bottom part will connect here. So we've got basically a cone on the bottom. So this bottom piece makes a cone as it spins around, right? We get this cone. And then this top part gives us a cylinder. So the radius of this circle here is 2. The height here is 3. So when we find the volume of a cylinder, it's going to be the area of the base times the height. The area of the base, so the base is a circle, so pi times the radius, which is 2 squared. 2 squared is 4, so I'll just write the area as 4 pi for that base. And then remember, the height of that cylinder is 3. So the volume here is going to be the area of the base, 4 pi times the height, 3. So the volume of the top part is going to be 12 pi. Then we can find the volume of this bottom part, so of the cone. So remember, this radius is still 2. And now we can look at the height here is also 3. So it's a cone with the same base and the same height. So it's just going to be a third of this, because remember, volume is equal to area of the base times the height divided by 3. So we already know the base area here is 12 pi. We also know the height is 3, and then we're going to divide by 3. So those will just cancel. Oh, wait, hold on, 4 pi. I lied about that. The base area is 4 pi. Sorry, base area here is 4 pi. Okay, so 4 pi times 3 divided by 3, so those 3's are going to cancel. So the volume of that cone is 4 pi. So then our total volume, we'll just add the cylinder, which is 12 pi, plus the cone, which is 4 pi. Whoops. So our total volume of this shape is going to be 16 pi. And then units, so just units cubed here. Oops. All right, let's just rewrite it. So 16 pi and then units cubed.